Hi, I'm Bryce Dixon. I'm a C++ programmer, and recently I've been investigating the speed differences between object-oriented programming and data-oriented programming. Um, this is a tweet that I made recently, and I was going to leave it at just this, but then I wanted to investigate it a little bit further. Um, Basically, what I was doing here is I made a specific scenario to test the speed of looking up data in an array of structs versus a struct of arrays, the object-oriented versus the data-oriented approach. Um, and it's fairly easy to see that the struct of arrays on the right is significantly faster than an array of structs. This is a fairly known thing, but I didn't realize how wide the disparity would be. And I go into detail a little bit on like why I made the choices I did in this specific test, but I figured I would just make a video explaining as well as going into a little bit more detail. So this specific scenario that I have a random number generation class to just generate some numbers. Am using the using directive to just specify all of my stats are 32-bit unsigned integers. I make a character class for the object-oriented approach with some stats in it. And I also gave it half a kilobyte of padding to simulate the idea that these characters might have more to them than just these few stats. Maybe there is a name, or maybe there is some like character class data. Uh, just imagine that there's a larger structure behind this that I couldn't be bothered to fill out for this pure speed test. And then at the bottom, I have another class to hold character stats, and then I have vectors of all of these stats. And then I've given this class a mplaceback method that is similar to vectors. You just give it the character you want to emplace, and it splits up all of that data into the different arrays for you. And then I've got these two different benchmarking functions that are basically doing the same thing. It's just one of them is working on a vector of characters, and the other is working on this character stat structure of vectors. And you can see the results on the right. The struct of arrays is about 12 times faster than an array of structs. And I thought that was interesting. But the one thing that stuck out to me was that this is kind of annoying to work with. If every time I wanted to go and make a new interface for dealing with complex amounts of data, to have to go and make this vector of whatever and then make sure that it's all ordered correctly. And because if I reorder it and maybe I'm using a different version of a DLL or something, then I break ABI, and then that can cause issues, which are very hard to debug. And, more or less just maintaining object-oriented structures is a little easier because your data is kind of partitioned a little bit. You've got your character class that might contain another struct that could contain other structs, versus where you have an array or a struct of arrays. Now everything's kind of in the same space. And so I was thinking, is there a way to better formalize this data-oriented approach? And so if I hop over to Compiler Explorer, I have tried to do that. And I've called this generic class a schema. And this is fairly convoluted to look at, but I will go ahead and explain what I did in detail. First, I have a variadic template argument. And if you've never seen this before, CPPReference.com has a great page explaining it. If you just search variadic template argument in C++, you get this parameter pack page. It was very useful the first time I had to look this up. But the short of this is, this basically lets me type as many template arguments as I want, and then I can unpack them using kind of neat syntax later in the class. So I've got this schema that is templated to however many things I want it to contain. And I'm actually inheriting from an std tuple of variadic unpacking std vector of the types. And that basically just gives me this same structure before. I can make a schema of a bunch of stats, and it will split them all up into different vectors for me. I apologize for switching back and forth between a light theme site and a dark theme site. QuickBench does not have a dark theme at the moment. I have some using directives to just make my life a little bit easier. I have a base class. Column ID and entry ID are both just size t. Entry data type is what I use to create entries. And that way I can have a entry data type, which is like a tuple of things. It might be like a row contents, whereas each vector is kind of the column contents, if you want to think of it in a SQL style database schema, which is why I kind of named it this. I've got a create entry method and create entries method, which just allow me to insert data, and I'll show how that's used a little bit lower. And then I've got a get column, which is more or less just a wrapper around get. The reason that I implemented this is because normally std get, you have to give the type if you want to get a value by type. And there's a reason I wanted this to be possible, and I'll show it in a little bit. But because this is actually a tuple of vectors and not a tuple of types, I wanted to make it a little bit cleaner to just say get column of this type, rather than get a vector of this type from this schema. And then I figured, why not add the column index variant? And then this is just a helper method for creating an entry similar to tuple instantiation. If you've never seen this before, I'd highly recommend just pausing and taking a glance over to try to understand it. More or less, I'm just looping over every index of the entry data that I get, which is a tuple of types. I just loop over every index of that tuple and then insert that value into the correct vector. I scroll down a little bit. I then have this namespace character, and this is where I hold all of my different types. I've got like a health type, an attack type, and a level type. And then I've got this name type, which is a little bit bigger than I needed it to be. I wanted to round out this a little bit. Originally, it was just an array of 64 characters so that I could have all of the names kind of packed together at a fixed length. And then I figured, I may as well give it like a const char pointer constructor, because std array doesn't have that. And I figured I should give it a string view operator and have it handle printing to ostream, so I can make that a little bit easier for myself. This is a lot longer than it should be. Just know that name type is an array of 64 characters. And then I make my character schema. I make a schema using the using directive again. This is very nice way of intentionally instantiating a variant of a template class. I have a schema that I want to have characters name, level, health, and attack, and I just called that characters. And I could call it character table, character schema. I just went with characters because it's shorter. Though, to be fair, it might make some of this look confusing because I have character and characters with an S. Just know that they are separate. And the characters with an S is the schema. Character is just namespace with some type defs. Then at the very end, I go back to making another namespace character block to just add entry, which is just a alias to characters entry ID. I can have character entry to make more of a entity component system style of syntax. This was all the setup at the top. Down at the bottom, I have the actual program where I make a static character schema table, and I just called it C. Then I have main, which just creates some entries, and I create entries in two different ways. I created an entry, just one, and I don't track the return. Created multiple entries in just a array, and then I create an entry again, but I actually tracked that return value so that I can reference it later. Then I just print out some data. I print out the first column, 0th column, the 0th entries. That would be the 0th column is the name, and then the 0th entry is Alice's name. And so that's why I print out Alice here. Then I print out the third column, 4th entries. Third column is the attack. And the 4th entry is Emily's attack. And so that's why I print out that value. Then we get to the reason why I wanted to kind of add that get column functionality. I can say rather than memorizing or creating an enum for all of the different entries, I can actually say, hey, give me the level type. Give me the level of Frank, because I held on to that entry ID from earlier. And I have to static cast it to an int because this is a uint 8, which is going to be interpreted as a character. And if you print out a character, it will print white space because it's not. This value is a non-printable character. It's 2. But if I cast it to an int so that we can see it, you can see it actually does print 2, which is the level of Frank, which you can see here. One caveat to this implementation is if I try to print out the health type, I will actually get a compilation error. The reason for that is because both health and attack are uint 64s. And so the compiler can't determine which uint 64 we want to retrieve. The way around this is, rather than just aliasing a type, I can actually... Okay. Yeah, there we go. I can actually make a struct for health type and then just give it a value. And then I gave it some implicit constructor to copy the value, and I gave it some operators to cast the value. And that way I can actually discern between health type, which is a struct now, and attack type, which is just a uint64t. And ideally, I could make a templatized struct for this as well, which kind of takes care of all this for me. But this works well enough for an example. But this is what I wanted to show, is primarily this more generic data-oriented approach, which is a bit easier to maintain. If I wanted to add or remove a new type, for example, if I wanted to add defense to my character, I can now just duplicate this last line and change it from an attack type to a defense type. And of course, I have to add some extra values to all of my entries. To fill that type. And filing, fill, there. So now I've added defense, and it's going to have the same problem that health did when they both shared the same type, where you can't get them by type. But I could actually remedy that by just changing this, and like this, and now it'll be considered different. And so if I do defense type, I can actually print the defense type of Frank, which is 0. They're all 0, but this is kind of, I thought this was interesting enough to make a video on. Normally I would just make a text blog post, and I will be posting this source code in a link in the description of the video if you want to dissect it a little bit more or make modifications. I just thought this was a very interesting way of handling a formalized approach to data-oriented programming, as opposed to just saying use structive arrays and you get lookup and entry gain speed gains. This is a way to actually make it more maintainable and more extensible. It's easier to add, remove, change types, etc., without having to go back and change all of your interfacing code. But if you stuck around this long, I really appreciate it. Like everyone else on YouTube, I appreciate ratings, and subscribe if this is a kind of thing that you're interested in. And if you want to check out some live coding of this style, feel free to follow me on Twitch as well. Thank you very much for watching.